Welcome to droidcon. Today we're going to be playing with some experimental features in the Kotlin language. So my name's Brent. I'm a staff engineer at American Express. Here's my About Me slide. So I'm originally from Canada. I lived in New York for about 6 years. I'm back in Canada now. Staff engineer at Amex. I used to run the Kotlin meetup here in New York, so I know a lot of you from that. Wrote a book, family of 4, have 2 dogs, and I have a couple hobbies, including I was a professional chocolatier for a while. Come ask me about that if you're interested. All right. So just to do like maybe a quick level set here, who's heard of Kotlin keeps before? Okay, like a third. So that's good. Okay, so we're going to start pretty maybe basic intro stuff, and this talk's going to ramp up as we go. Okay, so we've seen the Kotlin language evolve as we've used it, right? So if you're like me, you've been around since, pre 1.0 days, and some of the things we maybe take for granted now, 5 years ago looked like cool new features, right? I remember sealed classes coming out, and then shortly after sealed interfaces, things like being able to do trailing commas are like, oh, that's cool. Things like contracts. More recently, even if you've started using the language, since 1.7, 1.8, you've seen things like coroutines come out, data objects are new, some range operators, the definitely not null types that were pretty recent. So the language continues to move forward. And so this talk is a bit of what's coming next in Kotlin. So the language does continue to move forward. There are a bunch of proposals for what should be in the next versions of Kotlin. There are features in Kotlin right now that with compiler flags you can turn on and you can play with. There are different kind of stages of readiness. So in this talk, we're going to see what those are, and we're actually going to go play with some of them. But first of all is, where's the best place to find out about these new language features? So I mentioned Kotlin keeps. That's one option. There's a Git repo called Kotlin keeps that talks about some of these things. There's also utrack. There's also just like the official Kotlin documentation. So where's the best way to go find out about these? So we'll start with keeps. A keep stands for Kotlin Evolution and Enhancement Process. So it is a Git repo. Looks like this, right? So there's some issues, there's some PRs, there's things that have been merged in here under this proposals doc, and they're all markdown files, and you can go read them, right? So here's like the keep for Kotlin contracts, for example. Right, so they'll give some examples, how it should work. And so the idea with how this keep repository should work is that you open up a GitHub issue for any kind of current in progress keeps that people are discussing. And then, any new keeps or addition to keeps go through the regular PR process, and a bunch of people comment on them. And then once language feature is actually implemented, all that stuff gets closed, gets merged, and there's that proposals directory with markdown files. You can go kind of read the history of how they got to that point for this feature in the language. However, when you go actually look at that repo, you'll see there's like, at least at the time I wrote this, there's like 49 open keeps and 40 changes, which seems like a lot. Seems like too much. So when you actually go kind of look at the state of things, it's imperfect. There's a bunch of things that should probably be closed that are in the language. There's also language features that have been discussed publicly that don't have a keep. Like rich errors and things like name-based destructuring, which they talked about it, even the keynote at Kotlin Conf this year. Where do you go? Maybe U-Track, probably not. Good luck. U-Track is like a great place if you kind of know what you're looking at, but the signal to noise ratio is too high to just like keep an eye on everything or keep an ear to the ground for what's coming up in Kotlin. There's just too much going on there. There's some documentation on the actual Kotlin Lang org website. That looks like this. Right, so there's this page under the Kotlin evolution and roadmap called Language Features and Proposals. And so you can see here some of the things that have proposals, again, don't have keeps defined. Some things don't have U-Track issues defined. So this is a decent place to go kind of look at what's upcoming in the language. It's maybe the cleanest. It's still imperfect. The idea with this kind of official documentation is there's the tabs at the top. It talks about what is in exploration and design. Some of those don't have keeps yet. Once they get to the point of wanting external kind of contributions to what they're wanting to do in the language, a keep will open up and they'll link to a keep. And then there's this discussion that happens. Then goes into preview, which is, experimental, alpha, beta. And then a feature will finally go into stable or revoked, and then it's, in the language and ready to use. So some things that are in this exploration and design stage, which is, things to watch for that might be coming out in Kotlin, things like statics and static extensions, collection literals. We're going to talk about, rich errors. We're going to talk about name-based destructuring, better immutability using multi-field value classes. Yeah, so these are kind of some of the things we can expect to see in the next couple years. And things in discussion, again, are kind of further along this process and more likely to land in some sort of aspect. So there's moving some Kotlin X things into the standard lib for times. There's the atomics that we've seen. There's non-capturing type aliases, which we'll look at in this talk. Yeah, so some of these things are in discussion. And again, we're going to look at some of these. And then things that are in preview, even further along. So guard conditions, multi-dollar interpolation, non-local break and continue. Earlier this week, Kotlin 2.2 came out. So these might actually be out of preview. These might be stable now because these are actually in the 2.2 language. So if you're using 2.1, you have to turn these on with some compiler flags. At the time of this writing, these were still in preview. Recently, maybe, or at least soon, these will move out of preview to stable. But again, the website's imperfect. There's things like must use return values that aren't listed anywhere on the website. They do have a keep. So again, what's like the best place to go say, what can I do today with the version of Kotlin I have today? So I find just like giving this -x argument to the Kotlin compiler. Now if you're using Kotlin 2.1, it's going to tell you exactly which language features you can enable. If you're using 2.2, you're going to get a different set of arguments. So the docs are like -x gives you a synopsis of advanced options. So you give it -x, and I don't know if you can read this. There's a few of them. This list is not just like language features you can turn on. There's a lot of kind of neat arguments you can play with the compiler. So I would recommend at least doing this once and scrolling through. You'll find some things that might be kind of, interesting or neat that you want to go look at more. Maybe you can tweak or tune your build a bit. But if you just grep for, anything that's experimental in that list, you get a more, sane set of flags you can play with your version of Kotlin. So I formatted this output a bit so it looks nice, but more or less this is what you get, right? Yeah, and there's some things in here that are still Kotlin compiler arguments, but they don't actually do anything anymore, like the -x new inference, right? The new generic type inference has been used since, I think, Kotlin 1.3, right? So I don't know why they leave the argument in here. Probably just it doesn't hurt to leave it in. If you add it, it's not going to change your code. You might get a warning that says it's deprecated and not needed. Yeah, but a lot of the things in here are things we can play with. So any of those -x arguments, you're probably not compiling Kotlin from the command line. You're probably running through Gradle. So just your Kotlin compile tasks, you can add it as a compiler arg. Using the Gradle DSL for compiling Kotlin. So you add those, and now you can use these language features. Okay, so before we move on to code, okay, so we looked at keeps and kind of what their purpose is. Look kind of at utrack. Again, if there's a specific language feature that you're interested in either in a keep or utrack, your best thing is just to go follow that individual thing. You get notifications as they change. Yeah, and actually asking the compiler, hey, what can I do? Okay, so let's actually play with some of these language features. So these are the ones we're going to look at today. I mentioned the top three are now enabled by default in Kotlin 2.2. So if you're using 2.1, you still have to add these -x parameters to be able to use them. But they're definitely the safest to use because you know that once you update to 2.2, they're there for you to use without these arguments. So the other ones, they're still experimental. You can turn them on, but things might change in the language. If you're on 2.1, you kind of know what's coming in 2.2. So the top three really safe to use, and as we move through these, maybe less and less safe to use, but good to know about. There's also some things that have been announced and discussed. They're kind of in that discussion stage that aren't in the compiler yet. Name-based destructure and rich errors. So we're going to look at these as well. So we're going to look at kind of this set of things, which is 2.2 and 2.3 at the bottom, and then these might be in 2.4. So I guess a word of warning, should you actually use these, if they're experimental, you can play with them, put them in your toy projects, alpha things, expect some changes. Things that are beta, it's kind of up to you. There might be a few migration issues, but beta means it'll probably end up in the compiler for a while. And some language features, like contracts, for example, stay experimental for a long, long time, and they're, you kind of have to weigh yourself if they're safe to use. So some are, and then stable, of course, we're all using stable stuff already in Kotlin. Okay, let's code. So some of these things that are new in 2.2. I guess maybe another show of hands. So who's on the latest 2.2 that came out this week? Anyone actually using 2.2? Of course, Jake. And that's it. Yep. 2.1? Yeah. Yeah, we're at 2.1. Yeah. Is anyone still on 1.9? Okay. Yeah. So most people on 2.1. Cool. So you might have seen these already. Like I said, they're now in 2.2. So even if you're using 2.1, 2.0, you can turn them on. It's very, very safe to turn these on. So multi-dollar interpolation. The issue that was in Kotlin before this was, you can see in this multi-line string that I have, this $ schema, $ID. So those would try and use string templating and replace that as a variable, right? So you wouldn't have a variable named schema. You actually just want $ schema in this JSON output. But you don't have $ schema, so it wouldn't compile. And you can't just do an escape character in a multi-line string, because it actually just shows up as a backslash. And you can't do two so this temp fix you can see at the bottom here. I think you can see that. Yeah. So there were ways around this, but they weren't nice. So now you can do $2 and now single dollar signs just show up as dollar signs, and anything you want to replace as a variable you prefix with $2 signs. Kind of a fun thing with this is it doesn't have to be $2 signs. You could put $7 signs, and then anything that's prefixed with $7 signs gets replaced, in case you had some multi-line string that needs, $3 signs scattered around it. All right. Guard conditions. Okay, so this is essentially doing if statements within when conditions. So I apologize if this code is a little tiny. This is the smallest code sample I have. Everything else is a little bigger. Okay, so the example is you have some sealed interface that's an animal, and you have a cat and a dog class that are animals, and the cat has a Boolean that it's a mouse hunter. So in a function like feed animal that takes an animal, you can now say, if it's a dog, do something. If it's a cat, and the cat is a mouse hunter, you can do something. So you can now do an if condition within a when statement. Just a more kind of complex example, and maybe a more real-world example. You probably have, some sort of code like this in your app right now. I know we do. So you'll, get some sort of status back from, let's say, an API. It could be loading, or it could be an OK status, and you have some data, or you have an error. So when you actually act upon this, some result that is the status type, you could say, if it's loading, do something. If it's OK, if it's a status OK, and the info is empty, do something. Otherwise, you end up in the more general catch, or the more general when condition of just it is OK, and you'll do that. You can see on error, we can check types and stuff. So it really gives you kind of that type safety on the right side of the if statement. Okay, the last one that is available in 2.2 is non-local break and continue. See this line here that is continue that has a comment on it. Just looking at this code, this looks like it should be fine, right? We're in a for loop, and we have some condition, and we want to continue to the next item in that for loop. So this looks okay. However, in 2.1, without this -x non-local break and continue flag, this won't compile. And the reason is we're in a run lambda. You can see 2 lines up where we have a question mark, colon, like Elvis operator, run. So run is a lambda. So you don't actually know what kind of the scope is of that lambda. It could be passed around. So because of that, Kotlin wouldn't let you do a continue from within these. You now can, and I think the rules are, as long as the lambda is inline and can only be executed once, so those are kind of handled with all these standard lib, like run apply functions, and let, so Kotlin contracts kind of handles that for you. But, so now you can do this. If you got bit by this before, now you're okay. Okay, so getting into some things that will now start coming out in the next few years. So we'll start with context parameters. These used to be called context receivers. They've now been renamed to context parameters. 2 years ago at droidcon 2023, I gave a full 40-minute talk about context receivers. So there is, it's a deep topic. You can spend 40 minutes talking about it. I'm going to give it 2. So, if you're interested, go do some more research on these. So first of all, they used to be called context receivers. They're now called context parameters. So if you're used to context receivers, you now just have to give them names. So if I go between these slides, you'll see there's very little difference. If you're only used to context, or if you haven't seen these before, kind of ignore context receivers because they don't exist anymore, where Kotlin has decided to move forward with context parameters where these things actually need names. Okay, so you can see we can mark a function with this keyword context. And this is actually a modifier on function, just like override or abstract or infix. It is not a function that you're calling. It's actually a keyword modifier on a function, or like suspend, something like that. So this could be one line. You could have context blah blah blah, fun blah blah blah, one line. It is part of the function definition. So you say which object or objects need to be in context for you to call this function. So you'll see I have two functions. They say that you need a logger to be able to call them. Now within that function, I can use that logger and just call functions on the logger. So similar to passing just regular parameters to a function, but kind of what's the advantage here? Let's say I had, in this with statement at the bottom, let's say I had 10 different functions that all needed a logger. You would see like having to pass a logger everywhere all the time. And a context can have like 5 things, right? Or 2 things, as many things as you want. So again, a lot of cases you end up like passing a lot of parameters around, and it's just sort of noise in your code. So one thing this does is gets rid of that. This is a much more complicated example with context parameters, so bear with me, but I think it kind of highlights a lot of important things. So first of all, you can see we can have a context not on a function, but on a property, right? This is a val, and it's actually an extension property. 2, you can use an underscore if you want the parameter to be implicitly in scope, which is kind of cool. Yeah, so the idea here is that this like 2px function exists on a compose interface called density, and this is a real example, by the way. So it exists on on an interface called density, and in that interface there is an extension function called 2px. So the kind of ideal thing where this as px function that I'm writing exists would be in that interface, but I don't own that interface, right? So this lets me say that that interface has to be in context on the thing that I'm calling this as px function on for it to make sense. I guess the other thing this maybe highlights is a great use of context parameters are cases where you have an extension function, but it feels like I want to extend 2 things, right? In this case, dp offset and also density, but you can't extend 2 things in in an extension function. But with context parameters, you can force it. So at compile time, you have to have both of those things. Okay, so where these are useful, again, just something has to be in context when it's called. It also makes sense for like scopes. Some of their examples talk about DSLs. So a good example I saw was if you had an infix function for each month on int, then you could have a DSL that's like 10 space March space 2025. And that would be like a cool part of a DSL if you had some, calendar DSL that you were trying to write. But it would also mean if you wrote that code today, that if someone had your library on the class path, they could use that syntax anywhere, which doesn't really make sense outside of your DSL. So now if you had those infix functions, you could just say the context has to be whatever the scope is above in the, the DSL function, the receiver type I'm using, and now you can only use those kind of DSL constructs within the actual DSL, just not kind of anywhere randomly. This is also going to be pretty big for dependency injection. If you think about functions needing parameters in context before you can call them, and a chain of those things, you kind of get dependency injection that's enforced at compile time. So that's pretty cool. We'll expect to see some things from Coin and stuff to really make use of these to give you more compile time checking in your DI libraries. All right. Some things in 2.3. So must use return values. So you can turn this on with this -x return value checker. So check, just make sure it's actually being done. Full will add some annotations for you to your code, or you can disable it. And disable is kind of the default right now, but as this is enabled in the future for different Kotlin languages, if you wanted to turn it off, there's kind of this kill switch. Okay, so and JetBrains and Kotlin are actually investing in this one quite a lot. There's maybe 3 things in here that are really important. I think context parameters are one. Must-use return values are something else where we're going to see changes in the way we can code things in Kotlin. So how this works right now is you can add this @checkReturnValue value to either a file or a class. You cannot add it to just a single function, but if you have it on a file or a class, you can turn off needing to check return values for individual functions. So a few reasons they did this. They thought if we needed to add @checkReturnValue to any function that you want to enforce checking the return value from, in the end, every function in the standard library is going to end up needing it, and they kind of want this to be the default. So adding it to kind of higher level things makes sense, and turning it off for smaller things, again, make more sense. They also can't just turn this on blanketly across everything right now, because again, like they said, the migration cost of doing this would be really high. We can expect some compilation error. We can actually expect some compilation errors when we start to do this. So they're already underway of adding these annotations to standard library functions and the Kotlin X functions. So if you go, look at source code and you see these annotations, that's what they're for. Again, they're not going to do anything until probably Kotlin 2.3 unless you turn on that compiler flag. But here's the idea. If you call this charge function for this person and you get back a result, this is fine. This is okay. If you do not assign the return value of a function to a variable, we're going to start seeing compilation errors. If you want to explicitly ignore what comes back from a function, you can do this new syntax val underscore. We already use underscores in a lot of places to ignore things, right? Destructuring, if you don't care, you can use underscores. Lambda parameters, if you don't care about them, you can use underscores. So there's already some examples of this in the language. So this feels like it makes sense. Could change, but this is what they're proposing right now. So what people at JetBrains have said is, if a function returns a value, it does it for a reason. It's very easy to accidentally call a function, like maybe close on a file, and not know that it's returning a Boolean that says if that operation was successful or not. So now we're going to have compile time checking that makes sure that if something returns a value, you have to handle that value. So this is very similar to Go. I don't know who's used Go before. This is a little bit of Go code. So Go doesn't really have the idea of exceptions that can be thrown. They kind of use this needing to handle return values to do error checking in Go. So the first 2 lines I'm just calling charge. So you'll get a compilation error here because charge is returning an error and you're not doing anything with it. Next line, I can assign that to this error value. And if you don't actually use error anywhere, you again get a compilation error. So you're kind of forced, okay, this thing returns an error, I have to assign that to a variable. I now have a variable, I'm forced to use this variable. This is kind of how error handling works in Go. Go also has multi-return types. So you might have a result, comma, error as a return. You have to assign both of them and check both of them. And again, if you don't care about it, you can use an underscore. So we might see this affect how we write some Kotlin code, because now we could return just result types, right? And a result type can be a success or an error. And now you're forced to deal with the fact that you have a result, and you gotta, see if it's a success or not. Okay. Non-capturing type aliases. So you can turn this on with -x nested type aliases. And I actually tried to write pretty much this exact code and got a compilation error like a couple weeks ago. So you might have been bit by this as well. It feels like you should be able to put a type alias inside of a class, right? But you do it and you'll get the red squiggles and the compilers say you can't do that, they have to be top level. Like all type aliases have to be top level. So you just move it up to the top and things are good. It feels kind of, it feels kind of strange. So with nested type aliases, this is now okay. We can now put a type alias within a class or within a function, right? We can move the scope of the type alias, and that type alias can only be used in that class or that function. There's a few kind of extra things around this, like if the type alias is referencing like an inner class to the class that you're in, you can now mark your type aliases as private, so that you don't kind of leak the scope of nested or inner classes outside of the scope where they should be usable. So you can also do private type aliases now. There's a few other nuances, but more or less it just if you thought you could do this before and you couldn't, now you will be able to. This is probably another one that's pretty safe to turn on. The footprint of this is pretty low, and if you had problems, it's pretty easy to kind of refactor if something here changes. Okay, so annotation use site targets. So a use site target for annotations is where you have like at something : and then your annotation, right? So you've probably seen these on like at field : my annotation, etc. And there's a few of these, parameters, fields, gets, properties, and the parameter in your setter function. So this is valid code. If I had a var that was in a constructor, so at param, in your compiled, JVM bytecode, you would see this at email annotation on the constructor parameter. Field is for the backing field, get is on the getter, property is for the property reference, etc. You can now just do this, which is kind of nice, right? You can just say at all, and I want this annotation on all of the things. And it applies it just to the places that are valid for this case, right? If this was a val, not a var, there wouldn't be one on the set param, for example. If it's not a constructor parameter, it wouldn't be on parameter, right? So it applies this annotation to anything that is valid for this class or variable. So kind of nice. I know I've been bit before by some DI stuff where you're trying to annotate with inject, but it's you just say at inject, and it should be at field inject, and it doesn't work, and you're trying to figure out why. All might be a bit of a shotgun approach, but it'll at least know if the things are working right, and then you can maybe fine-tune it after that. All right. Now we're going to look at some things that may or may not be in Kotlin 2.4. These are things that you cannot play with in the language yet, They're still kind of in this discussion phase. They were mentioned at the Kotlin Conf keynote, so some version of this will probably happen. And again, we're looking at 2.4, so this is a few years away, but exciting things to see nonetheless. So first one, name-based destructuring. Most people don't do destructuring in Kotlin because it is pretty unsafe to do, right? The common example is this, right? I have a person, well, it's a data class that has a first and last name. This code is fine. If I were to change that data class person to have 3 fields instead and change the order so that the data class was first, middle, last, this code still compiles, but now my last name is assigned to a variable called first and my middle name is assigned to a variable called last. So, and no compilation issues. Depending on your tests could still probably pass. So kind of risky to use destructuring. So they've gone back and forth on what the syntax of this will be. This is what they're proposing right now. They were going to do something with braces. So this is what the proposal is right now, which I kind of like. So you can put, the vals in your parentheses, and this is fine. Now first will get assigned to first, and last will get assigned to last. So this looks at the actual field names. So if I swap the order of these, this still compiles fine, and my last name field from person is going to always be assigned to a field called, or a variable called last name. This fails because there's no field called larst in person, right? So this makes destructuring safe. It makes it something we might actually start using in Kotlin, which will be nice. Rich errors, also called union types, also mentioned during the keynote. So you might see some code in your project like this right now. So I'll have a function called findPerson that may or may not return a person, a function called charge that may or may not return a balance. So now instead of returning nulls, I can do a pipe operator and some sort of error type. So this is where union types come from. So the things on the right have to be kind of these new error types. So I can return a success type or this error type. The thing on the right, you now prefix your objects or classes or data classes with a new keyword called error. That means I can now use them on the right side of that pipe operator. And now when I get back a result, I'm forced to check if it's kind of the valid case or any of those error cases. So here's kind of the full example. I have my 2 error things. I have my 2 functions that are going to return either a success case, pipe, or kind of one of those error cases. I call find, and then I'm forced, again, at compile time, to deal with result as it could be a balance or it could be one of these errors. The maybe interesting thing here is after I call findPerson, I still use the question mark operator as though it could be null. So that is the syntax they're proposing right now. So findPerson can't return null, but if it were to return an error, result is going to be assigned to that error type. If it's not an error type, it's going to continue on the right-hand side of that question mark operator and call charge. And again, you could chain these as long as you want, right? You could have 5 question marks like we do right now. So much safer than what we do now. Here I'm calling findPerson and I'm calling charge, and if it doesn't work, I don't really know what happened, right? It could have been find or charge that caused the issue, so this helps with that. All right, we're at the end. This is what we looked at today. Again, the first few, pretty safe. Even if you're using 2.1, go enable them. If you're using 2.2, you don't have to enable them, just start using them. We've seen Kotlin kind of evolve nicely over the last few years as we've used it, and it's nice to see that the language is continuing to move forward with some cool things that'll make our lives as developers easier. All right. Yeah, thank you very much. We're out of time for questions, but I'll be over here if anyone wants to chat.